Okay, so we're going to talk about trigonometry, trig for short. And we're actually going to focus on coordinate systems. Coordinate systems. So, in physics, well, right now at least, we are dealing with two different types of coordinate systems. We're dealing with polar and Cartesian. So let's focus on Cartesian. Cartesian coordinates are the coordinates you already know. So you have an x and you have a y. So if I gave you the coordinate 2, 3, how would you graph it? You would go over 1, 2, and then you would go up 3. 1, 2, 3. Cartesian is x first and y first. You should be already pretty familiar with Cartesian. Now, polar. Polar is different a lot. So we have r and we have theta. So r is our radius, theta is our angle. So if I gave you the polar coordinate 5, 90 degrees, don't get intimidated by this. It's really simple actually. So our radius is 5. So we would go out 5. 1, 2, 3, 4, 5. And the 90, we would rotate this point 90 degrees around the plane. So it actually is 90 degrees is a full rotation to here. If I was 545, I would only rotate halfway. My point would be here. And remember, the angle always starts here. So it's just a different way from plotting points. And we're going to go over how to convert from Cartesian to polar and polar to Cartesian. So let's get a grid here. So let's say I have the Cartesian coordinate, which means Cartesian is x and y. So 5, 5. Now you can tell the difference between Cartesian and polar coordinates because remember, with polar, we have radius and angle. And this symbol is just a fancy sign for angle. You'll see it a lot in geometry. And so an easy way to tell is if they give you an angle, like 90 degrees, it will have that little angle sign there. So this is Cartesian. So how would we plot it? We would go 5 across, 1, 2, 3, 4, 5, and 5 up. 1, 2, 3, 4, 5. That's our point. Now, let's say I needed this in polar coordinates. So converting from Cartesian to polar coordinates, you're going to need to understand geometry a bit. So if we look at this point and we look at the origin of our graph, we can actually create a triangle. And so we know this length, it's 5, and we know this length, it's 5. So what we need to know is the hypotenuse, which would be our r, and our angle, which would be the theta. So finding r, is easy. You just do, um, actually, you need absolute value. Actually, no, don't need absolute value. Forget I said that. So finding r, we would do, remember, finding the hypotenuse of a triangle is a squared plus b squared equals c squared. So let's go to a calculator. Calculator. We would do 5 times 5, because that's what 5 squared is, plus 5 times 5, and we have 50. I'm looking for a square root. Okay, there it is. So the square root of 50, which was our answer, which is 7.07. So we're just going to round and say, so we are converting to polar, so we have our radius 7.07. Now we need to find our angle. And in geometry, you should have learned about SOHCAHTOA, which it's an acronym. So the sine of the angle, which is a fancy button on the calculator, it looks like SIN. So the sine of this angle here, we use the theta symbol, should equal opposite over hypotenuse. Okay, don't get intimidated by that. Opposite just means the side of the triangle away from the angle. And hypotenuse is our long side. So the angle, the sine of the angle equals opposite over hypotenuse. So in this case, it's 5 over 7.07. But that's not our actual angle, that's the sine of the angle. And so on the calculator and in math, there's a special function. It's called sine inverse, which just looks like, where do I write this? Sine, but with a -1 symbol there. So if we do, go away. So if we do the sine inverse of the sine of the angle, those cancel out and leave us with the angle. But we need to do the sine inverse to our other side. So really the angle equals the sine inverse of 5 over 7.0. So it doesn't look like that on, it doesn't look like there's a sine inverse there. So I'll just look up sine inverse, and maybe I can find it. Okay, so sine inverse, and there will be a button on this on your calculator. So we'll do the sine inverse of 5 divided by 7.07 equals about 45 degrees, which, if you think about it, look at our triangle. That is a 45-degree angle. And the reason it's not exactly 45 is because we rounded when doing the square root of a squared plus b squared equals c squared. So our angle would be 45 degrees. So that's how you convert from Cartesian to polar. And now we need to know about converting polar to Cartesian. And remember, polar is just a different way of graphing. Okay, so let's say I have, okay, just a real quick note. If you're dealing with a problem and it gives you a negative angle, just do 360 plus that negative angle. So if it gave me negative 90, it'd be like going this way, but in all your calculations, you start here and go counterclockwise. So you want to convert that to the bigger angle. So just do 360 plus that negative angle. So let's say I have the angle, not the angle, the polar coordinate 4 and 270 degrees. And so I'll go out 4, 1, 2, 3, 4, and 270 degrees is just 3 right angles. So you'd go like 1, 2, 3. It's just a quarter circle, and then you would. So this would be where we plot our polar point. Okay. So you need to have this remembered, but to find x, so we need to find x and y of that point. If we didn't have a graph, we couldn't figure it out. Or if we had a funky angle, we couldn't figure it out exactly. So the formula for finding x is x equals the cosine of the angle 270 degrees times the radius, which is 4. So here, x equals cosine of theta times r. And then y equals the sine of the angle times 4. And so yeah, we'll do y equals the sine of the angle times 4. So write those down, or make sure you remember it for the test. Remember, y is cosine, y is sine. So let's calculate that out and see what we get. So we have our sine calculator open already. So the sine of, it was 270. It's negative 1. Okay. Negative 1 times 4 is negative 4. And remember, that's our y. Now, is there a cosine? No, there's not. So I'll just look up cosine calculator. And the cosine of our angle, which is 270, equals negative 0, which is just 0. 0 times 4 is 0. Now look at our point here. It's down 4, negative 4, and it's across 0, 0. So that's how you convert from polar to Cartesian. X equals cosine of theta times r, and y equals the sine of theta times r. Now just a real quick review. A Cartesian is the points you are already familiar with. Okay, x, y, easy to plot. Polar is the new grid system. It gives you a radius and it gives you an angle. And you're going to need to know how to convert from those two. And so in the homework, there was a problem which consisted of a fountain, and I'm not quite sure what the problem actually was, but anywhere where you can draw a triangle, you're probably going to be dealing with polar and Cartesian coordinates. And look, this triangle, it might seem like, what's my polar coordinates? But remember, the triangle will have an angle, and it will have a hypotenuse. And if it's wanting, let's say there's a a ladder that leans against a wall and at an angle of 45 degrees from the ground. How high is the wall if the ladder is like 7 feet? Well, in this case, h is a height. H is height, which is our y. So imagine we just had a graph here. H would be our y. And so we can represent this, if it was 45 degrees, we can represent this triangle, this ladder, as a polar coordinate, 7 and 45 degrees. And h we can represent as our y. So all we need to do is convert this to Cartesian coordinates, and then y is our height. And it wanted to ask how far away is the base of the ladder. That would be our x. And that is coordinate systems for you.